Right. In our previous class, we started with router's initial configuration. We know how to go under an interface, say no shutdown. We know how to um, assign IP address. Now you see there are some good show commands that we always need to know. The first one you see, show IP interface brief. Don't forget this command, show IP interface brief, is going to show you all the interface and their status, whether it is up or down. Yeah, you know this. We use this command. Have you used this command, Ray? Yes. Next is, if you want to know the interface speed, duplex, what is duplex? Duplex, the communication stream, like, if we say half duplex, only one side communication. Full duplex, two-way communication. Let me repeat again. Between two routers, you have a wire. If this wire can send and receive at the same time, then it is full duplex. If it can send or receive at a time, if it can send or receive, then it is half duplex. Give an example for half duplex. Any one of you, give an example for half duplex. Okay, give an example for full duplex. It doesn't need to be a networking example. It can be any example. Ah, cell phone, any phone, two-way communication. You can talk and he can also talk. Whereas in half duplex, when one side is talking, the other side will be listening, and vice versa. Both cannot do same thing at the same time. Whereas in the full duplex, when this is sending, this will receive. When this is sending, this will receive. This happens simultaneously, parallelly. That is full duplex. Half duplex example, real world example. That is also correct. Don't say wireless. I know what you are trying to say. You are trying to say the walkie-talkie, correct? So walkie-talkie, one person will talk, the other person will listen, and after the talk, they will say over, so that the other person will release the button and he will talk. Sorry, press the button and he will talk. That is walkie-talkie. One-way communication. Sorry, not one-way communication, half duplex communication. Walkie-talkie is a nice example. So if you want to know about the interface speed, bandwidth, the delay on the interface, encapsulation type on the interface, duplex on the interface, you may use this command, show interface. Now, the protocol that is running on the interface If you want to know, then you type show IP interface. All IP related only will be seen. Whereas in this, not only IP related, some IP related, most of hardware related will be seen. Speed, duplexing. You know this command show IP route. This command show IP route, and then you put one particular address and check whether that address route is available or not. There is also one command show IP route static, meaning it will show only static route. Show IP route OSPF. It will show only OSPF route. Yeah? Next, in order to see what has been configured on this interface, you can type show IP interface brief to see all interface status in one table. You can also type by see by typing like this. Show running. In the running configuration, show me this interface. What has been configured in this interface? You see, there is a command called show history. Show history command will show recently used 10 commands. Recently used 10 commands. If you want to have more than 10, then you need to use this command. Terminal history size, some big number. If you increase the buffer size, then more commands, more recent entries, many lines you can see. Do you understand show history? I want to know what all I have typed last 10 times. Last 10 line of commands. Then you just type show history. But I want to see 20 line of history. Then try increasing the memory and see whether 20 line it can accommodate. If it is not 20 line, then increase again. 200 MB, 250 MB, increase. Now, if you want to type the same command that which you typed recently, use the up arrow. So it will recall the command that you have typed from the history. Either you press Control P or use up arrow. Better use up arrow. Having used this, you should try using this. Again, let me show you this. So to increase the size, we have to go to the privilege mode and type this. Terminal history size 250 or terminal history size any number between 1 to 256. Yeah, we give 250. And after that we checked show history. We can see many lines. And also I was telling you that the up arrow will work. Look at this. If I want to know what command I typed, I can press up arrow. See? Now, if I want to change this, I can change it. I did not type the command. I used the up arrow because I typed the same command earlier. I can simply use the up arrow to bring it And now do show history. Okay, though I made 50, this is from the old buffer, but from now on, the size is decreased. It will not show this many. What I'm trying to say is use the up arrow if you want to repeat the same commands. For example, I want to see what it is. It won't work, no? And I want to see interface brief. I did not type the command because I typed earlier. I can use the up arrow to recall. That's what you saw here, recall. It'll come from the history buffer. Okay, routing decisions. Excellent, beautiful picture. A nice picture you see here. The PCs are creating the packet using OSI 7 layers. And the packets move from the PC to the first router, router 1. And router 1 is checking layer 1, layer 2, and layer 3 in the packet. In the layer 3 header, it reads the destination IP. For that destination, the routing table says you need to go to router 2. So it is sending to router 2. Again, router 2, what it does, it opens the packet, layer 1, layer 2, layer 3. It opens the packet. See, it opens the packet. In this packet, there are 7 layers, but it opens up to layer 3 to know the destination. This process is called de-encapsulation. This is encapsulation. It is encapsulating. And this is decapsulating. And this is again encapsulating. After knowing the destination, it wraps that cover. It puts the cover back and send the packet to the next router so that it can be sent to the destination. Next router again decapsulate it. De-encapsulating it, meaning it removes, looks the header, layer 3 header, router 3. After knowing the destination, it covers it back, it puts the cover back, it encapsulates it back, and then send to the destination. And destination, because it's a computer, it will read all 7 layers and it will open the data and show in the monitor. Do you have any question? This is what I explained now. See? First step, it opens the packet, checks the MAC address. Is this my MAC? Router will check whether it is my MAC address. Is it my MAC address? Yes. Then it will check the layer 3 header and it will know the destination. So for the destination, router will pick the best path. From the routing table, it will know the best path to send it. And then again, router, what it does, it covers layer 3, it covers layer 2, it puts new layer 2 frame, meaning I want to explain this in more detail. Wait. This is very, very important fundamental. This picture is not quite clear. I will take this picture, I'll do some changes and okay. Now, from this computer, I'm sending packet to what computer? 192, 168. Read, no, just read. This is the computer to which you are sending. 4 dot. Hello. Yes. 4.10. And see, these are all MAC addresses 0A10, 0010, 0020. These are all MAC addresses. So this PC from source IP, what is the source IP? 192.168.1.10. From this source to the destination, it wants to send the packet. It will put its own MAC address, which is 0A10. And what will be the destination MAC address, you know? It will be the MAC address of the gateway. Not this MAC address. Not this MAC address. Destination MAC address will be the next router's MAC address. What is the next router's MAC address? 0010. So when this packet goes to this router, it will open that layer 1 and then it will open layer 2. In layer 2, it will check whether this MAC address and my MAC address is matching. If it only matches, it will again open layer 3 and check whether this IP address, I know. It checks the routing table, whether it checks whether I know it or not. By checking the routing table, it understands it needs to send to router 2. So what it will do now, it will cover layer 3 and layer 2 it will change. Layer 2, it will put its exit interface MAC address 0020 and the next router's MAC address 0B31 and send this packet to router 2. Now the packet received on router 2 checks the layer 2 address. Is this my MAC address? Yes, it is my MAC address. Now it will check the routing table. Do I know this? Yes, I know. I need to send to router 3. Fine. Router 3, then I need to change this MAC address. What will be the exit MAC address? You know, it will be the MAC address of router 2 and MAC address of router 3. It is not mentioned here. I'll just put router 2, router 3. So it goes to router 3. Again, router 3 will check the routing table. It delivers the packet by changing the MAC address. So if you see now, every hop, the MAC address changes. But the IP address never changes. You're not following me. What I was telling you, every hop, MAC address will change. IP address won't change. That is what mentioned here. You see, a new layer 2 frame is added. Why? Because MAC address changes, no? Layer 2 data link addresses change every hop. You understood? So this is what I was talking to you. You see, when the PC is sending this packet, it needs to know the gateway MAC address. This is gateway. So it is using ARP. From the ARP, it knows the MAC address of the gateway. So it puts the MAC address of the next router, not the MAC address of the final computer. If you see the IP address is the IP address of the final computer. Source IP address is the sender's computer's IP. But the MAC address is not the final destination MAC address. It will be the immediate next hop MAC address. How it knows the next hop MAC address? From the ARP table, it knows. In the ARP table, how do you see the ARP table? Show ARP. Show ARP in the routing table, in the router. If you want to see in your computer, in your laptop, go to command prompt and type ARP-A. It will show you your immediate next router's MAC address. Okay. All right. So once router 1 receives the packet, this is what I just explained, but I'm repeating again. After router 1 receives the packet, it will check whether I know the destination. Yes, I know the destination. This 4 network, I know. I need to send it to router 2. This is router 2's IP address. Okay, then it will again go and check the ARP table in router 1 for 192.168.2.2. All right, and then it changes the MAC address and it keeps sending like this. You see the destination MAC address is the MAC address of router 2. So now router 2 will check the routing table. It understands that the packet needs to go to router 3 via this place. So it again looks into the ARP table and copies the MAC address and forwards it. Okay. Okay, now how the routing decision is made. You see, a packet is coming inside the router via an interface. Now router will check the routing table for the match, the destination match. Does the destination IP address matches the subset of the routing table? Now, if the match is on the directly connected interface, see, if you check the routing table, show IP route, you see there's something called directly connected, meaning the network is on the same router. That is what it is checking. Is it directly connected? If it is yes, check the ARP cache and forward the packet because it is local. If it is not directly connected, then it is a remote network. Do you have the route for the remote network? If you say yes, then you see the next hop router and use the MAC address from the ARP table as we saw in the early pages, encapsulate it and send it. If there is no remote network, is there a gateway of the last result available? Means, do we have any default route or gateway assigned? If yes, encapsulate it, send to that gateway. If no, which means there is no route in the routing table, router cannot route the packet, so send it to garbage. Please understand, I repeat, a packet is coming inside a router. Now, it will decapsulate and take the destination IP address and try to match with the routing table. If it is matching with the directly connected, Then use the ARP table, know the MAC address, put the MAC address and send it to that host computer connected. If it is not directly connected, is it remote network? If yes, the route is available, then change the MAC address of the layer 2 with the MAC address of the next hub router, encapsulate it and send it via the exit interface. If there is no route in the routing table, check whether any default gateway configured. Use the default gateway and send it via that exit interface. If none of this is seen, then the router cannot route the packet. Just put the packet into the garbage. When there is no route, how can router forward? So that's what I was telling you in the previous class. You need to give route statically or using dynamic routing protocol. That is what this page explains. Okay, now this much we have covered. Let us go to the next page with a fresh mind. Hop count versus bandwidth as a metric. Why they are discussing this now? You see, we are going to learn about various type of routing protocols like RIP, Routing Information Protocol, OSPF, Open Shortest Path First Protocol, EIGRP, Enhanced Interior Gateway Routing Protocol. So we are going to do these routing protocols. You see, routing protocol's job is to give route. Then why these many protocols? Routing protocol's job is to dynamically learn routes to the remote destinations. Now, question is, why do we need these many routing protocols? It is because, answer is here. Each routing protocol has got their own rules and metrics to build and update the routing table. Every routing protocol has got their own rules and metrics. For example, RIP uses hop count. OSPF uses cost that are calculated based on bandwidth. Now you see that's the reason why the topic has come, bandwidth versus hop count. It is like RIP versus OSPF. We'll talk about that, but before that, let's talk about this. EIGRP uses bandwidth, delay, load, reliability. Now, coming to the point. Why do we need more? Why do we have more than one routing protocol? Because they have their own rules and metrics. When you know what rules they follow, you can pick the one whose rule is better for you. See, if you say OSPF rules I like, you can run OSPF as the routing protocol in your environment. If you say hop count is what I want in my network, then you can go with RIP protocol. So according to your need, you can pick one protocol. That's why we have this many protocols. People are not of same taste. Everyone has got different taste. Likewise, in networking also, not everyone has got same policy. Different people will have different policy. For some, Oxwagon is best. You know what is Oxwagon? Hello? Oxwagon? இந்தியாவில் இருந்துட்டு ஆக்ஸ்வேகன் எனக்கு தெரியாதுன்னு. ஆக்ஸ்வேகன் வெங்கட் மாட்டு வண்டி தெரியுமா? அதான் சார் ஆக்ஸ்வேகன். அதான் இங்கிலீஷ்ல ஆக்ஸ்வேகன் சொல்லுவாங்க. So some likes Oxwagon. For them that is their favorite. மாட்டு வண்டியில போறதுனா அவ்வளோ இஷ்டம் எனக்கு. எங்க மாட்டு வண்டியே பார்க்க முடியுது இப்பெல்லாம் அப்படின்னுவாங்க. See, that is their wish. Some will say, I want to have a horse ride, kudura savari. That is their wish. So that is why you have both the Volkswagen as well as horse wagon. குதிரை வண்டியில போறனா குதிரை வண்டியில போங்க, மாட்டு வண்டியில போறனா மாட்டு வண்டியில போங்க. உங்க இருக்கு. ரெண்டு வண்டியும் இருக்கு. You understand why we have more than one routing protocol? You can pick what you like. Every protocol has got their own rules and metrics. Whichever you like, if you like OSPF rules and metrics, pick OSPF. If you like RIP rules and metrics, pick RIP. For Prem, you understand why we have more than one routing protocol? Now let us try to understand the difference between the routing protocol that uses bandwidth as a metric and the routing protocol that uses hop count as a metric. You see, what is the bandwidth here? Just 256 KB. You know what is the bandwidth here? It is 1500 KB. Now, if you check the hop count, traffic comes here, goes here, and goes here. Why? Because this is the less hop. Only how many? Route 1, 2, 3 jumps. But if you take the other path, 1, 2, 3, 4 jumps. So going via router 2 is 4 hops. Going straight from router 1 to router, what is this? Router 3 is, that path is only 3 hops. So this hop count protocol will say 3 hop is better. So this is the best path. According to RIP, this is the best path. But according to OSPF, that is not the best path. According to OSPF, this is the best path. You know why? The bandwidth. This is 1500 KB. T1 means what? 1500 kilobits. You see, this is only 56 kilobits. Instead of going through this congested road, even though it is only one stopping, listen carefully. Only one stop, but going through a market. சந்தை வழியா ஊர்ல சந்தை இருக்கும் போது கார் எடுத்துன்னு போய் பாருங்க தெரியும். சாயந்தரமா சந்தைக்குள்ள நுழைஞ்சு அந்த பக்கம் போகணும். கிட்டதான், ஆனா போக மாட்டீங்க, சுத்தின்னு போவீங்க. ஏன்? கன்ஜெஷன். Because it is too congested. Even though it is short, even though it is just one hop, you won't go like that because the bandwidth is very less. These people in the market are everywhere, blocking the way. So you will go by taking a long route. because the bandwidth is more. கொஞ்சம் தூரமா இருந்தாலும் பரவாயில்லைங்க, இப்படி போயிட்டோம்னா 5 நிமிஷத்துல போயிடலாம். இப்படி போனோம்னா அரை மணி நேரம் ஆனாலும் போக முடியாது. பேண்ட்வித் கம்மி தான். பேண்ட்வித் கம்மி மட்டும் இல்லாம ஆட்களும் அதிகம். மார்க்கெட் ரோடு இங்க கொஞ்சம் தூரமா இருந்தாலும் பேண்ட்வித் அதிகமா இருக்கிறதுனால சர்ன்னு போயிடலாம் பாருங்க அப்படின்னு சொல்லுது ஓஎஸ்பி. So both the protocol have got their own rules and metrics. Whichever suits your requirement, you pick. அடே நான் பொடி நிறைய நடந்து போறவங்க, எனக்கு எதுக்குங்க இப்படி சுத்தின்னு போகணும், என்ன கார்லயா போறேன் அப்படின்னு நினைக்கிறவங்க இப்படி போயிடுவாங்க. ரிப்பே போதும் சாமி எனக்கு, நான் அனுப்புறதான் சின்ன சின்ன பேக்கெட், தம் தூள் பேக்கெட், இப்படியே போயிடுறேன் அப்படின்னு. My packets are too tiny, less than 56 KB. Then why should I take a long route? I'll run RIP. Others will say, no, my packets are too big. It will not go this way. It will take long time. Even if it is long route, I'm okay with this one. Then they will run OSPF. You understand why they choose different protocol? Because they got different environment. Everyone is not having same environment. So tell me, is RIP a bad protocol? No. According to the need, when we use, all protocols are good. சும்மாவே சொல்லுவாங்க ரிப்பு அதெல்லாம் வேஸ்ட்டுங்க, அதெல்லாம் வந்து பழைய ப்ரோட்டோகாலுங்க, எல்லாருமோ சொல்லுவான். இப்பதான் நெட்வொர்க்கிங் தொடங்கி இருப்பான் படிக்கிறதுக்கு. இவர் அப்படியே பழங்காலத்துல இருந்து இருக்கிற மாதிரி ஒரு பழைய ப்ரோட்டோகாலுங்க, அதெல்லாம் யார் யூஸ் பண்றா அப்படின்னு பேசின்னு இருப்பான். Not like that. Every protocol is important. It is important in their own environment. Is this clear? Now, thank you. If you see, I have 3 paths to go from R1 to R3. This is one path. This is another path. This is another path. How many paths we have? 3 paths. But நம்மளே கதை விடலாம். But assume this is also T1. But the traffic will go this way only. Why? Because this is also T1 and there is only one link. Only one link. Only one link. Here it is T1 plus T1, 2 links. 2 links, more costly. So it will go this way. Packet will go this way. But instead of T1, let's say here you have only 56 kbps. T1 means I told you it's 1500 kbps. Now, will this path be considered? No. Bandwidth, if you use OSPF, it won't consider because of the bandwidth. So it will take only this path, 2T1, this path, 2T1. You see, both look similar. Do you agree? Is the path both looking similar, equal? If it is equal, then it will send the packets equally via both the paths to the same destination. So if it wants to go from here to here with 500 packet, it will send a 250 packet this way, 250 packet this way. We call it as equal cost load balancing. So when you do load balancing, what is the advantage? Quickly you can reach the destination, isn't it? Quick communication, which is increasing the effectiveness and performance of the network. Do you understand? Right? So equal cost load balancing can be configured in both dynamic routing protocol as well as static routing protocol. Now, there is one protocol, only one protocol, which can even support unequal cost load balancing. That we will learn when we go to EIGRP. But understand what is equal cost, unequal cost. Equal cost means paths with same metric. This is having same metric as this. There is equal cost path. Unequal cost path means this metric and this metric is not same, but still you can do load balancing if you have EIGRP. No other protocol will support. Only EIGRP will support unequal cost load balancing. Now, with this page, I'm going to conclude the class. You see, there is something called administrative distance. Very, 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 very important page. And equal cost load balancing. Sorry, administrative distance. Unequal cost load balancing is the previous page. Administrative distance. What it is. We just saw that there are many protocols. RAPE, OSPF, EIGRP. Now, what if I have all the protocols in same router? If I have all the protocols in same router, which one to follow is determined by administrative distance. Which one to follow is determined by administrative distance. Let me ask you a question. You have your old friend and you have your new friend and you have someone on the road and you have a relative and you have a brother. Now you want to ask something very important, or you want to know something very important. Now everyone is giving one answer. Your brother is giving one answer, your relative is giving another answer, your someone on the road is giving one answer, your new friend gave one answer, your old friend gave one answer. For the same problem, everyone is giving different suggestion. Which one you will follow? Can you follow all of them? No, you cannot follow all of them because you want to buy only one car. You have money only to buy one car. One guy is saying you buy Benz. Another guy is saying you buy Scorpio. Another friend is saying you buy Skoda. Another friend is saying no, buy BMW. Another guy is saying say buy Audi. Now you cannot buy all. You want a car, but everyone is giving different answer. Your brother is saying, hey, don't buy this big car, costly car, man. You need a future. You need to save something for future. Now you buy one simple car for the school, for family. Later you can, when you're old, you can buy one luxury car when your body is too tired. Now one simple car is enough. Buy one small Brio or something small. So everyone gave different answer for your question, but you're not going to follow all of them. You're going to follow the one whom you trust more. You're going to follow the one who whom you trust more. Likewise, router also will follow only the protocol which it is trusting more. All this may be running on the router. All this routing protocol may be running on the router, OSPF, connected, static route, blah, 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 blah. Which one it will follow? It will follow whose administrative distance is lower. Administrative distance need to be lower in order to be preferred. See, your relatives are closer, but your brother is more closer. The distance between you and your brother is very small, very close compared to the distance between you and your relative. That's why we used to say, no, he's my relative. That man is a distant relative. Hmm? So there is some number involved in that distant. How far? How closer? More closer, lower. That is what. Connected is more closer. You need to follow that instead of following OSPF. OSP will say go this way, but connected says no, come this way. Which one you should follow? Connected. That is why for connected they have given small number. So this number smaller means more you trust. I ask you a question now. Answer. This router is running OSPF. This router is running EIGRP. Both the routers are telling path. EIGRP is saying go via the red line. OSPF is saying go via the blue line. Where? To go to this network. A dot, B dot, C dot, D. EIGRP in this router says go via the red line. OSPF in the router says go via the green line. Tell me which line the packet will be forwarded. Exactly. Why, sir? Prem, sir. Prem, sir. Prem. Oh, shortest path line. Because that has got small number administrative distance. OSPF is 110. Smaller is trusted more. 90 is trusted more. All right. So lower administrative distance is more trustworthy. With this, we'll stop.